Okay, guys. Now, we just have a cis. We have an alkene here that is cis, yes? Let's find out how we can get a trans, right? Because if we have a cis, maybe we have a way of finding a trans. So, here's this. What is that? Hello? What is that?
It's an internal.
So what did you say? Are you hiding information from me? Next thing we are going to use is lithium or sodium, whichever one of the two, lithium metal or sodium metal. I am used to lithium metal, but in the book it says sodium metal because I happen to read it. Did you guys read the book? Well, I'm not taking the class and I read the book. So, and ammonia. When you treat this internal alkyne, doesn't have to be internal though, it could be terminal too, with lithium or sodium and ammonia, you are going to get a trans alkene. So the hydrogens will add to the opposite sides. And this is trans. So you know how to make a cis, and now you should know how to make a trans. Can you see that? If I write bigger, can you see it?
It's okay, I just watched the videos.
That's why I write them. I mean, that's why I record them for the champions. Because the ones that watch them one time, I wouldn't do it for you guys. Because you got Mitch, yeah? Guys, who wants to learn the mechanism for this?
Of course. It's part of orgo.
You guys are getting tired of mechanism? Yeah, by popular demand, let's do it. I ask you to give you the false impression that you have anything to do with it. No, really, you want it?
Yes.
It's not in your book. It's not in this book. But then I read another book and I found it in another book, so I'm going to give it to you. Guys, nobody's interested in knowing that? Okay, let's see if I remember it, okay? If I remember it, then you'll have to know it. If I don't remember it, then you don't have to know. Let's say lithium or sodium and ammonia. It's possible I don't remember it, okay? All right?
Impossible.
No, it's very possible. Why are you laughing? I got something in my back. What do you think the lithium or the sodium are doing there? What are they? No, they're not positive charges.
They're ions.
Ions.
Oh, no, my...
Radicals?
Radicals. It's lithium metal or sodium metal. It is the one from the periodic table. So it is sodium that is not charged. It is sodium that has one electron. And what does sodium like to do to this one electron? Give it away quickly. She ain't waiting for nothing. She wants to give it away fast. She doesn't think? She doesn't think about anything. She's ain't gonna roll like this. So, it is a radical. okay?
Yeah.
It is a radical, but it's not. It's one electron that is given, but when we draw things with a radical, and next chapter, you are going to have radicals, okay? Lots of them. This is a radical, and this is
An arrow.
Radical.
this is one electron.
That's
A double-headed arrow is 2 electrons, okay?
catalytic, right?
So the sodium is going to give this electron to this carbon.
How come it only has 1 electron to give?
Sodium?
Yeah.
Because it's in group 1A of the periodic table.
Oh. Should I go back to 1046?
No, that's not even 1046.
So why, Professor, why do we have the sodium?
1045.
What
That's
happened?
ammonia.
Why do we have?
That's not so.
Oh.
Nitrogen? Which nitrogen are you talking about?
No, when the pneumonia, where she has the egg, she got
Pneumonia. No, not pneumonia.
ammonia. Okay, yeah, she saw the two. She saw the two lone pairs, and then you have one over there, so she got confused.
Oh, okay. All right. Well, the pneumonia, not yet, okay? All right, so here's what happens. Here's a pi bond, yes?
Yeah.
One of these electrons from the pi bond is going to go, you see that? What happened?
Going to the carbon.
Okay.
Yeah.
But it's gonna be
This electron here either goes to this carbon or to this carbon. It's got to go to a carbon. It can't go to the middle of the bond, yes?
right.
It has to go to one of the carbons. It went to this carbon. If it goes to this carbon, this, from this pi bond, another one is going to go that way. And of course, this pi bond was made of how many electrons? 2. So the other electron is going to go to this carbon. Woof.
So then that carbon's just going to have 1.
I don't know what's going to happen. We're going to draw it right now. So what is going to happen is this carbon here will have a minus charge. Yes or no? With a CH3 and another CH3 here with that radical. Yes?
Yep.
Now we have ammonia around, and the pKa of that is greater than that of ammonia. So what is going to happen is this electron pair is going to get that hydrogen from ammonia. I should call it hydronium, yes? And this is going to give us a hydrogen and a CH3 on one side. Now, the other CH3, and remember, what are we trying to do here? What does this give us?
Trans.
Trans. The other one was 6 because they're both added from the same site, yes?
Right.
But this one gives you trans, and the reason why it gives you trans, because in the middle of all this thing, you are going to have a carbon. You're going to have an alkene, and this alkene is going to have how many groups on it? If it's an internal alkyne, it has 2 groups on it, yes? Now, which one is more favored? The alkene that is cis or the alkenes that is trans? Trans. A trans alkene is more favored. So this is going to become, in the process of stability, is going to become trans. Well, right now there is an electron pair here. What is going to happen? Another electron pair is going to be donated for sodium to this, and that will form this. Because an intermediate step is an alkene. The biggest 2 groups, they want to be opposite to each other because of
Steric strain.
hindrance.
Yes, steric hindrance.
Okay, you can call it steric strain as well. And what is going to happen is another hydrogen is going to be taken away from this ammonia, And what you are going to form is the trans. How did you like that one? What? Forgetting? Oh. Oh yeah, well, I tried to forget, but I couldn't. That first part was unforgettable. All you care about is the first impressions, yes? This did not make an impression on you, Rahim? The sodium? No? Made an impression on me?
The way you explained it, yeah, it kind of did.
That's precisely the point, man. Okay, guys. All right. You guys remember 1046, yes? Right? The pKa of this is about 25. And the pKa of this is about 38, 36, 38. So, which is the weaker acid? The one on the right. Which conjugate base would be stronger?
The conjugate base of that.
The conjugate base of this. How would the conjugate base of this look like?
NH2. Yeah, minus.
Outstanding. That cannot exist by itself. What does it have to have next to it? What?
No.
Na. Whenever you see Na, NH2, this is a very strong base. It's called sodium amide. And this is how that base would look like. Because this pKa is very low. Okay, there's the explanation for that. Is we treat this with sodium amide and a solvent, yes? I didn't put the salt. Whatever. This base is going to do what?
Okay. The hydrogen.
It will pull this proton off to form. This is an acid-base reaction to form this carbo anion. The sodium plus next to it plus NH3. Do I really care about NH3?
No.
No. What I care about is the organic product. Yes? If you remember this in this class but don't remember this, you've learned nothing. If you remember this in this class and don't remember that, you have learned something. Okay?
We don't need to draw arrows for this one.
You want arrows for this one?
Because then I'm going to look back on it and I'm going to say, oh, what attack was?
And you like the attacks, huh?
I don't like the attack.
No, I never said if you like being attacked. Who's attacked you? That's why you carry that pepper spray, yes?
Yes.
All right.
Wait, can you draw the arrow?
No, you are supposed to know how to draw the arrows. Why don't you draw the arrows? How about that?
I'm asking you this clearly.
No, why don't everybody draw the arrows for that? You do it. Put the charges on the thing and draw the arrows. You are supposed to know from 1046. I can't show you everything. I'm not going to live forever. Did Miami Heat play today?
So they play tonight too.
They played yesterday?
Yep.
They won. Well, 3.
No, it wasn't by 3.
No, we beat them down. Like 11
It
points.
felt like 5, but it wasn't like 5. It was not even technically.
We were winning by 10 points.
Yeah, but at the end, no, we won by like 6 or 8 points. Not even. And not even, like these.
Hey, where are you going?
That was 30.
Excuse me?
Like 99.
She's going to the movies? She's gonna see 50 Shades of You're gonna go see Cinderella?
Yes. It's beautiful.
Really?
Yeah.
Isn't that a kid movie? Okay, good for you. Okay, guys. This is an acid-base reaction. You are supposed to know this from before. Okay? Here is a carbon with a hydrogen. Here is the base, which I already drew this base for you. And you know that a base does what? Attack what? Pull an acidic proton. Which one is the acidic proton? Well, I got one. That acidic proton is the same as this acidic proton. They both have a pKa of 0.5. So this is going to pull that off, and electron pairs are going to go to this carbon. So what this is going to form is this, negatively charged. So what does this look like right now? That looks like a nucleophile. Outstanding. What else does it look like? It also looks like a base. Looks like a nucleophile, looks like a base. So what do nucleophiles like to do?
They like to take electrons.
They like to what?
Take a proton.
Bond, yeah, they bond.
They attack the electrophiles.
They like to attack the electrophiles. Which ones are the electrophiles?
Positive.
The ones that are positive. Outstanding. So, guess the purpose of this reaction is only so you make a nucleophile. So this nucleophile can then go and attack other things. So, if I make this, or this, which is the same, if I make this and I add then an electrophile in there, what's going to happen? The nucleophile is going to attack the electrophile. The electrophiles we are going to use here are alkyl halides. How does an alkyl halide look like?
Halogen with a
Let's not complicate it too much, okay? Let's do baby stuff first. You want to do baby stuff first?
Yeah.
Let's not make it so baby. So, you have this, yes? You made this. And then you add this to it, and this is this, right? CH3 with a halogen, this is called an alkyl halide. If you put that nucleophile is going to do what? It's going to attack this carbon. Because this carbon is delta positive while this one is delta negative. Any nucleophile will attack that carbon. Any of them. And when you take the next, not the next chapter, but the chapter after that, you're going to have 1 million nucleophiles attacking that one. But here, we are just doing baby things right now. This nucleophile is going to do what? Attack this carbon. It will attack this carbon from the opposite side to the BR, from the back.
The BR gonna leave?
That's right. The BR cannot stay, right? Because if you're making a new bond here, this BR has to leave, and it goes and takes the electrons with it. So this is called the nucleophile. This is called the electrophile. That's right, and because the BR leaves, it is called the leaving group.
That's how to make an alkene.
What?
That's how to make an alkene. The reaction.
To make a what?
An alkene. Is that a reaction?
An alkene? No, that reaction is called chain elongation. How's that, guys? Exciting, this exam you got next week. Man, I can't wait. You guys are going to be the best organic 1 class in the state of Florida.
Not the whole nation.
Not the whole nation yet, but by the time we're done, you're gonna be in the whole world, including aliens. So, after this, you are going to have this, yes? It attack, this BR left, and what you are going to have is the triple bond, and what's on this triple bond now? A carbon with a hydrogen, and another hydrogen. It had 1, 2, and 3 hydrogens, did it not?
Yes.
So, what you have done here is you have added a carbon to your alkyne. What you have done here is you have made your chain bigger by 1 carbon. This is why this reaction is a chain elongation. Because it makes the chain bigger. You know? You know what elongation is? Yeah. Elongation is better pronounced elongation. Labice, why are you laughing, man?
Oh my God.
Okay?
So when the nucleophile attacks, you know from the back, the BR is going to leave, and that nucleophile takes the place of the BR pretty much.
Yes.
So the BR can bond later on to it.
No, the BR is not going to bond to anything. The BR is now sodium. From the sodium there, and then bromide. BR is a spectator ion. It's chilling. Let's keep that.
How, on the test, how would we know, like, since we were presented with that, do we
Elongation.
assume that we're going to have an alkyl halide, or are you going to give it to us?
I am not going to give it to you. You are going to give it to me.
Like, so if I'm going to go from that very beginning to what you're drawing
Yes.
now?
I just showed you how this works. Well, I haven't even began explaining this.
Wait,
But what does this do?
Chain
Yeah, and bonding.
That's, well, that's a carbon here,
But
but
it-
that's carbons. Could be 1 or it could be 2 or 3. What were you going to say?
wait, you just said you're not done, right?
No, I'm not done, but you
Okay.
can ask a question that is for the future.
So if you want
What
to,
happens to ammonia?
Ammonia,
I don't know, NH, what is it?
she gone.
She's gone.
She's gone.
I'm going to the BR.
It's NH3, she's gone.
Spectator.
She evaporates.
Is that a nice way of saying she died?
Well, she didn't die, it's just she got kicked out, you know.
Oh yeah, that's right. It's never created her. Right.
That's right. Okay, so this is how this works, okay? I am going to, I just told you how to preparate something or to prepare, preparate. Is that a word? Is that a word, preparate?
Yeah, that is.
I don't know,
a
it's
word.
not like you guys know it.
That is
You
a
guys are
word.
not English majors.
Preparation.
Let's say I have this and this. In the first step of this business, I add this to it. What did that do to it? It formed what?
nucleophile.
Nucleophile. In the second step, I added this alkyl halide. Provide the product.
Oh, okay.
Okay, so you
Just
are
the-
going to give it to us? Like
Well,
part
I'm not
two?
done. You are going to give it to me too. I give it to you and you give it to me.
So we don't have to do the part you created the nucleophile, right? Just the product.
What happened?
We don't have to do the mechanism for the nucleophile, then do the product.
No, you,
Okay.
well, what do you mean you don't have to do the mechanism?
Like now, you
Making
just
the
give.
nucleophile.
Oh, you
Oh,
mean for this specific
yeah,
example?
yeah.
Yes, you don't have to know
Okay,
this.
Okay.
By the way, this mechanism you see here, this mechanism is called nucleophilic substitution by molecular. And this is in 2 chapters. You are going to have a million of these, okay? Right now, I'm not saying what this is, none of it.
No,
I'm
yeah,
just giving a little, like I said, we're just getting you wet.
This one is SN2.
SN2.
So for us to have a strong
It won't do it at all.
It won't do it at all.
When we're drawing it out, can we go directly to the nucleophile?
No, not to the nucleophile, to the product.
Oh,
Not for this one, you don't. Okay, guys, so now we are here. And I just want the product. On the first one, you are going to create the nucleophile. And all that is going to do is chain elongation.
Yeah.
It will make this chain longer, or it will make an addition that is as many alkyl halide carbons as this has.
Yeah.
How many carbons does this have? Two. So after the double bond, it will make this 2 carbons longer.
CH2, CH3. Yeah. Do we have to add the BR? No?
Well,
Like BR minus?
guys, don't worry about the BR,
Okay.
because I
not
care
the
about
organic.
that organic product. Yeah, for sure. You want to do things right, you want to live forever, here you go. 93,
Plus
okay,
BR.
and this is what you want? Okay, then more for you to learn. Go ahead.
sorry, Professor, that's all we have to do?
Yeah.
Yeah, you want more?
So
Okay,
that,
she wants
no,
more.
no, that you, what you just did previous is just to explain to us how we get that, right?
Yes. Previous stuff is called mechanism and explanation.
Okay, so
And
on the
this
test,
stuff
you're
is
just gonna
used-
say, provide the mechanism or provide the product, okay.
On the test, I'll give you, for example, if I give you this and this on the test, and I tell you, provide the mechanism how you get from here to the product. You gotta give me the product, and you gotta give me the mechanism for this, which looks like that.
Okay.
Yes? If I don't ask you, give me the mechanism, then you don't have to worry. But she wanted more, didn't she?
I just thought we were gonna go through all the steps, that's all.
How many acidic hydrogens does this have? It has 2. So theoretically, we can say, in step 1, I can add this. Yes? And in step 2, I can add this. And in step 3, I can add this. And in step 4, I can add, let's make it fun, yes? I can add that. I'll provide the product. You know, I was thinking it's a lot of material, right? What should we do? I know what we can do. Let's make the test the entire time, yes? Longer. Right?
Why are you smiling?
It is an evil smile, that's right.
Smile.
Yes.
You can allow flashlights. Open book. No, open notes.
Guys, don't stare at me, do the product.
I have a point.
We're doing all of this, so the hard part is coming.
Okay.
This is just... Okay, so hurry up. Why are you looking at the watch? You want to go home already? Because you got here late. And you want to go already? I'm watching it. What's the answer? Give me the name of it.
Okay.
Okay, so look here. This is the alkyne. Chain elongation when you see this sodium business and an alkyl halide after. On one side, you are going to put this CH3, yes?
Mm-hmm.
So I'm going to put the CH3 on one side.
Right.
On the other side, I am just going to take the chlorine out
Uh-huh.
and put the triple bond.
Fine. Yeah.
That's it. What about CH3 for the BR?
What about the CH3 for the
Huh?
Wait,
CH3 for the BR?
The CH3 that
that is
came
the
with the
CH,
BR.
that is the CH3 that came with BR. But where did the other hydrogen go?
Like the 4?
This is the CH3 that came with the BR. And
Oh,
this
okay.
is the
Okay,
isopropyl that came with the chloride.
Alright,
Okay,
okay.
The isopropyl chloride.
Where did the hydrogens
Do I have
that were in the
different-
original? Like,
Just
we started off with 2 hydrogens, right?
The hydrogens are in ammonia.
Oh, okay.
They got pulled off, yes?
Mm-hmm.
Oh, right here.
They're not spectators.
So it was,
Sodium bromide are spectators. Ammonia, I don't know what ammonia is.
so this one we would have sodium bromine and sodium chloride.
Sodium bromine.
Sodium NaBr. We would have the NaBr from the first section and then NaCl from the second section, right?
Yeah, whatever you say.
Bromide, sodium bromide.
Okay, you guys ready? Let's do some of the difficult stuff, okay?
What do you say, NaBr?
So far, everything has been easy.
Guys, you get sodium bromide, sodium chloride?
It has been easy, can't stay this easy, okay? You ready? This is called retrosynthesis. When you take organic 2, you are going to do lots of this retrosynthesis from what I have been told.
Wait, Professor, before we move on,
One bar.
Who has one bar?
One bar. Battery.
One what?
One bar.
One bar?
Yeah, for the battery.
Okay, stop it right now for a minute.
wait, Professor, can I ask you a question?